Hello, this is another calculus video. So in the video immediately preceding this, I introduced the idea of integration by parts. Integration by parts is a way of taking a difficult expression that you're asked to integrate and making it simpler using the basic formula that the integral of u dv equals uv minus the integral of v du. Say that 10 times fast. The integral of u dv equals uv minus the integral of v du. Anyway, it has a ring to it. So if we apply that, let's do an example. So here is an expression, e to the x sine of x, that we're asked to integrate. And what do we do with this? Well, if we can find a way to fit it into this pattern of the integral of udv, then we can play with it. So let's go ahead, and what we want to do is we want to set the udv. We want to set the dv to something that is easily integrated. Well, you may have to experiment, which one you try, but e to the x is very easily integrated because the integral of e to the x is e to the x. The derivative of e to the x is e to the x. It's a very simple thing. So let's go ahead and set u as equal to the sine of x and dv as equal to e to the x. So now we have the integral of u dv, u sine of x, dv, e to the x. All right, so we plug that into the formula. The integral of u dv equals uv minus the integral of v du. So the integral of u dv, which is exactly what we started with, right? Just switch the order, equals uv. So u is sine of x, v is the integral of dv, which is e to the x, easy peasy, minus the integral of v du. So what is v? Well, we've just said v is the integral of dv, which is e to the x, du. Du is the derivative of sine of x. The derivative of the sine of x is the cosine of x. Okay, so here we have done it. We have integrated this somewhat difficult looking expression, and there you have it. Now, the thing is, you might look at this ex cosine of x and say, how is that any easier than this? Well, again, sometimes it's like following a maze. You don't, you keep going and you keep trying stuff. And you don't know where to lead all the time. And sometimes you hit a dead end and then beep, 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 have to reverse back and try something else. I mean, that's the nature of integration, unfortunately. But we haven't hit a dead end yet. Let's go ahead and take this part of it and use the integration by parts and let's just see what happens. Maybe something good will happen. All right. So let's go ahead and keep going. Okay, let me pause and get the thing going here. Okay, there we go. Now it's going to unfold. Oh, let's keep going. So let's go ahead and take this expression here, and let's see what happens when we integrate it by parts. All right. So we know that this is what we're trying to now. It's a sub part of it. We're going to try to integrate it. So let's go ahead and let's let dv equals e to the x again. And let's let u equal the cosine of x. So remember the integral of u dv. So we're going to let this equal dv, and we're going to let cosine equal u. All right. So applying the integration by parts formula, we have the integral of u dv, u cosine of x, dv, which is e to the x, equals uv. U is cosine of x. The integration of e to the x is e to the x. So that's v, integrated dv. All right. Minus the integral of v du. Well, what is v? V is the e to the x, the integration of that. Du, the integral of the cosine of x is the negative sine of x. And so there you have that. All right. So you might say, well, we're back where we started from. We're back to e to the x sine of the x. But here's where if we take this and we plug it back into this, all right? So this is where we started. This equals this minus this. If we plug what we found out this is back in, what happens? Let's look. If we plug that into the first equation, we have, this is what we're trying to solve for, equals, this is from the previous slide, and then I plug this in. So it's minus the integral of it. So it's minus that, minus, and a minus is a plus, but it's minus from the previous page. And so it ends up being a minus. And what do we have here? We have the same thing. If I add it to both sides, what happens? I end up with 2 times the sine of x e to the x dx equals, see what I did there? I added this to both sides and I ended up with 2 of them. So now all I have to do is divide both sides by 2, and I might go ahead and factor that e to the x out, and I have a solution. I have a solution to the integral of this. It's 1/2 e to the x times sine of x minus cosine of x, and of course, plus a constant. And there we've solved it. Isn't that amazing? And we didn't know where we were going, right? We were just trying stuff out, but it ended up in a good place. So there's another example of how to use integration by parts to solve what appears to be a fairly difficult integral.